Yes, so now I'm going to connect with what exactly we have discussed in the part one and part two. And let me remind quickly that in the part one, I have introduced you the different observational techniques, um, especially that was radar, LiDAR, solar, satellite, and radio sonde, rocket, and so on and so forth. In the second part, specifically, I have given you the glimpses of satellite observations and these satellite observations, why they are so important. And over the last like 2 decades, I think the satellite has completely changed the scenario of observations because you can quickly uh, take the view over the land as well as over sea and oceans. And you can understand on the larger scale widely that how the things are happening, how the transport is taking place, what is the role of the trace gases, and how your chemistry and interaction between, I mean, it depends on, sometimes the chemistry is dominant, sometimes the dynamics is very, very dominant. So the transport and the chemistry, both they work together. Therefore, in order to understand the atmospheric science, the contribution means as a whole coming from the fluid dynamics, from atmospheric chemistry, atmospheric physics, and computational sciences, they are all working together. And sometimes we also talk about like seismology and geophysicists, space scientists. I think this is a true interdisciplinary area where people can work together, they can help each other to understand uh, what are the concepts, what are the physical processes, and how we can really help each other. So now this is dedicated to the our environment, this particular part, and I would like to show you some of the recent observations of 2020 over Delhi, and some instruments I have put at my home at Dwarka and some at Rajdhani College, because as you know that for like 1.5 years, it has been a lockdown and there have been restrictions of the movement. So it was again challenging for us to study about the environment without going, and that was the only option left, that you do some kind of the remote sensing, and then you can learn a lot of things. How the lockdown period was totally different with the rest while I mean the past 1 decade, and then some differences of course we can compare with 2021. Okay, so the particulate matter distribution over Delhi I will show you. And what is the role of this variation of the wind, pressure, solar radiation, temperature, and humidity? So all these parameters, they contains both physics and chemistry. And some of the variation we can take like on daily basis. So you can average on daily basis, and some you can show hourly basis. So how in the diurnal variability is it changing? Diurnal variability means we are talking that every hour how it is changed and how it is changed over 24 hours, that is in one day. So these fine scale observations are very important to understand particulate matter concentration change with time. So this is our Geograph, and this is basically describing about variation of atmospheric pressure and PM2.5. In fact, uh, I would like to mention here that regarding the atmospheric parameters, this study is not uh, a very small study has been carried out, though people understand this, and specifically like atmospheric pressure. So from here, from this top panel, you can understand on the right side, this is the scale of the pressure, atmospheric pressure. So starting from 982 to 991, and only like less than 10 millibar change. Hectopascal or millibar is the same thing. And this is from 1st April, it goes to 8th April 2020. So this is one day. I'm talking about this one day observation. And PM 2.5 is shown here, concentration in microgram per meter cube up to 2020. Now, you know that in April 2020, already the lockdown was, I think, implemented from 23rd March 2020, and then it continued up to June, and then it reopened, then during winter again imposed, and then again reopened from Holi onwards, then again closed, something like that. So just focus here. The red curve, this one, this is your PM 2.5, and this is day to day. This is our like 0, 6, 12, 18, and 24. So this is one day observation. And these dots, they represent hourly data. Now you can see from here that PM 2.5 increasing between 6 to 12, that is around like 8, 9, 10 a.m. This is picking up, going up to like 100, 120 microgram, then coming down again, and then again going up next day and coming down in the afternoon, then going up next day. And of course, after like on 4th April, 4th, 5th, it was going high, high, high like this, and then coming down. But we just thought that whether atmospheric pressure is playing any role or not. And we, being from the science background, we understand that the few millibar pressure is making a lot of sense for the wind blowing from high pressure to the low pressure. So few millibar is enough to make changes. Now I show you this blue, this diagram. This is basically corresponding to pressure change. And can you focus your attention here that the pressure is high around when you are having PM 2.5 is high. So it means the high pressure is a very natural variability. So two times, one is here and one is around midnight. The two peaks, so these are the twin peaks in the pressure which changes in 24 hours. Then same here, then it is going up around here, then in the around just before midnight. Is a very systematic, and because this is what we call the semi-diurnal. Diurnal means 24 hours, semi-diurnal means like 12 hours. So every 12 hours you are having a natural variability, and at the same time it is consistently growing like this and coming down here. And at the same time, can you just see PM 2.5 increasing, 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 and coming down here. Now, what is the role of this? Do you think that from this few days to next few days, the sources are changed? I don't think so. Sources are not changed. Sources, because it was lockdown, so almost same. It was a natural variation. The pressure becomes few millibar high, and it has suppressed the vertical. Basically, we call this a index, ventilation index, and boundary layer, atmospheric boundary layer. So atmospheric boundary layer, if it is low, then it suppresses the vertical wind. And if there are less vertical wind, then the dispersion is also very less. So whatever is produced here, even during this period, that was water vapor. Of course, they get accumulated with the micron level particles, and you are having the formation of the PM 2.5. And whatever is coming from the kitchen and from like burning or from our daily activities, this is all accumulated, and we have experienced bit high here. But you remember, this is one parameter. What do you think about the wind speed? So whether wind speed is playing a role? Yes, absolutely. So the lower diagram here, this is your daily variation, 3 days, one peak. This is 2 p.m. and 6 p.m. here on this x-axis, and the wind speed is about like goes to 2.5 meter per second. So it is picking up in the afternoon around 3 p.m. almost every day with fluctuations, small fluctuations. And whenever there is a wind speed is high, going 1.5 or 2 meter per second, you can realize here that at the same time in the afternoon around here, the PM 2.5 concentration is less. Around here, 2.5 concentration is less. So wind speed, empirically, I think you can model that. And it is for sure that the wind speed is if it is going more than 2 meters per second, so it is sufficient to take away this PM 2.5 concentration from the city. At the same time, the natural variation, as I mentioned, of pressure, that is also playing a very, very important role. Let me include more parameters here. The top panel is the green is relative humidity in the atmosphere, and blue here is your every hour temperature variation. So can you see the blue line? And of course, again, it is like 1 week observation. On the x-axis, you can see April 1st to April 6th. So just follow this green line. In the afternoon, relative humidity decreases, and early morning, again, it is picking up. You can see that it goes up to 70, 75, 80%. And in the afternoon, it is coming down, then going up, coming down. But at the same time, you can see the peak to peak variability of relative humidity. Relative humidity is decreasing in the next 3-4 days here. So this is a natural process, of course. But what do you think about the direct consequence on temperature? So the temperature, we all understand that early morning around 6, it is minimum, around 6 minimum. And then it starts solar insolation increasing and temperature starts increasing. So when there is a peak here in the temperature, relative humidity is minimum. There is an anti-correlation, very clean anti-correlation here. And now you come back to this point that relative humidity was decreasing consistently, but at the same time from here, you can see that temperature was increasing. So within 3-4 days, the mean temperature from 27.5, it has touched 35 degrees centigrade. So within 1 week, so this was a drastic change in the temperature. And eventually we can see if the temperature is increasing, then definitely PM 2.5 is also reducing. Now you come back to PM 2.5 and solar radiation. I would like to connect with the solar radiation, pressure, and PM 2.5. This pink is pressure in this case, and as already mentioned in the previous slide, that there is a semi-diurnal variability in the pressure, and solar radiation is green, and solar radiation is related with the sun. So after the sunrise, the solar insolation increases, and its unit is watt per meter square. And we have closely watched this. Then whenever the value of the solar radiation exceeded like around 300, 350 watt per meter square, and we have seen that the PM 2.5 starts decreasing around here. So this is the value. The green is from this side, you can see around 300. So when it reaches around 300, then it starts decreasing. This is PM 2.5 variability and day-to-day variation, which you already seen in the previous graph. And the bottom panel is a very high resolution, 2 minutes interval on different days, and we have plotted this on 24 hours time scale. So you could see that around 7, 8, 9 during daytime, early morning, all the days, of course, on April 5th, it is high. Then April 4th, so maximizing around this time, early morning. And this is a kind of like physics we understood. And we published this paper last year in Nature Scientific Report. And we realized that after the evaporation of these small droplets, then solar radiation increases, it completely evaporates them, and the mist and the haze is quickly disappearing from the atmosphere. But before that, early morning, when there is a sharp increase around here. I will show you in the next view graph that at a high resolution in 24 hours, every 2 minutes, how you can understand the PM2.5 concentration variability. But before this, I think I must show a quick scenario on 8 stations over Delhi last year in the month of March and up to April. I mean, starting from March, 1st March and ending, I think this is end of like March completely. Of course, we extended this study, but not showing here. These are the different stations: Gurugram, Greater Noida, US Embassy. The blue dot is US Embassy, then Dwarka, Shadipur, ITU, Anand Vihar. So we all understand like at Anand Vihar, Dwarka, and Greater Noida. So these are like on the higher side around here. But the pattern over all stations, they are similar. And these are the rain impact over PM 2.5. So whenever there is a rain, that there is a washout effect immediately, and there's a huge reduction in PM 2.5, which you can see from here that on average it was like 100, 125, but suddenly then it reduced up to like less than 40, less than 30 microgram per meter cube. But the most important and the striking feature is this, that even in the Delhi city, the variability is like 100%. It's like something around here, it is like 75, but around some stations it is showing almost double at some of the stations. But US Embassy is a kind of like medium part, because that area is very close to rich and highly, I think anthropogenic activities are minimum, and that is a kind of like representation. If you average everything together, then probably you can understand a mean is something like this around here. Now, just to tell you that how the things changed in the lockdown quickly. So the bottom panel is at different stations, and blue is before lockdown, and this another color is showing during lockdown. So can you just see the two histogram at each station? At some, they are almost like maybe more than 50% reduction. In some, it may be 70%. So, but all stations have shown almost like 50% reduction, but the range was from 30 to 70%. It depends on the location of the station. So I'd like to show you a typical view graph of 24 hours and how we can understand the physics and chemistry of PM 2.5 variability. So this is a high resolution observation of smart sensor. I'm not carrying here, but maybe I can send that picture later. So high resolution. This is from midnight. It is going up to like maybe in the evening. And this horizontal line is 200 microgram. This is 400 microgram and 600 microgram around here. And this point, you know, early morning, as I said before, that we are having a mild fog, and the fog was of course increasing. And around here, this is your sunrise time, shooting up seems lifting of the tiny droplets around here. So sunrise around here, but suddenly after the sunrise, every minute PM 2.5 was increasing. And this happened only because whatever the droplets, the tiny droplets, in fact, they were lifting up. And because of the lifting, whether it is coming from the dew or coming from the leaves of the trees, and it is going up and mixing with the available submicron particles, and suddenly, because the lifting is happening because of the solar radiation, and PM2.5 increased. Remember here, because water content, water droplets is much more uh, tiny droplets in comparison to other uh, particulate matters, because when you call PM2.5, it may be sulfate, it may be nitrate, it may be dust particle, it may be silicon, it may be anything else. So this is another part of the story, that how do you identify that what kind of the particulate matter is available here, and what are the shape, what are their characteristics, how do they influence the health of the human being. But my basic objective is here to tell you that how this variation in PM2.5 at a very high resolution. So it took about like 60 days to me to realize this. Every day I took observations during lockdown, and then realized that this is all happening because of the evaporation. We then finally we published this paper, and they accepted without any much arguments. And the next peak I show you here around, this was a kitchen cooking peak, and I could not remove this, but the sensor is so good, so sensitive, that it can easily pick up within few minutes if there is any smoke coming from elsewhere. And you can see that even if you can use this like carry with you, and you can make a diary wherever you go during daytime, whether you go restaurant, you go to roadside, you go for a walk. So you can make a diary that you are exposed to PM2.5 concentration at different timings. So you can avoid those areas going if it is highly, uh, I mean, the concentration is high. But now what is happening here at 10, after 10 o'clock? So this arrow is solar radiation as soon as it crosses 300 watt per meter square, and wind speed is around 2 meter per second, and temperature is around 25 degrees, then there is a sudden drop. So all these parameters are favorable to wipe out this, to evaporate this, and relative humidity decreases, and atmosphere becomes so clean. And I think last year you might have seen that people have taken pictures from distance of Himalayas, and the Yamuna was so clean, Ganga was so clean, we couldn't do in the last 20 years, despite the fact of spending crores of rupees, 1,000 crores of rupees. So eventually, this was a very natural laboratory experiment. Uh, it happened only because of COVID. Otherwise, such scenario, nobody can uh, give you like as a laboratory uh, environment. I'll show you one more examples of 10th April 2020. And this is exactly similar as I mentioned before on 4th April. And you could see that from 6 to 10, this is very high. The same period when you are having the evaporation of the tiny droplets, they are basically mixing and going up. And we realize, I think I must share with you that it is not harmful, because most of them, they were water droplets, but they were of the order of like 2.5 micron. And because there was no pollution in the background. But this was a new, I think, finding for us, that you do not have anything in the background, but still you are having high values. So we need to distinguish this, that what kind of PM2 particulate matter you are talking about. And the same scenario happened here, that like in the afternoon, it reduced drastically. So during COVID, this we found it was touching to our, I think, standard WHO given values. Otherwise, always in Delhi and I think many cities of India, uh, the values are maybe like 5 to 10 times larger. We are dying, we are suffocating because of them. I think it's a big number, like maybe around 2.5 to 3 lakhs people, they die because of bad air quality. And the same I think happens like for when you talk about the road accident, the number is also very large. So these things I think probably the scientific community should come together and should study such kind of the topics which directly impact or influence the human health. And probably we need to work together. So I stop here. So this was a small introduction, and maybe some of you can have some good interest and you can continue to do some good research work in this particular area. So I stop here. Thank you very much. Thank you.